Next big idea is speed. You already know what speed is. What's speed? You have to know this so you don't get a ticket, especially coming to school in the morning. Watch out, it's the end of the month, right? Or is it the beginning of the month? Whatever, right? There you go. Some of you guys already have tickets on your record, I can tell. That's okay. What's speed? Speed is equal to what? Real simple. It's like 6th grade math. Speed is distance over time. There we go. Okay, speed is just how much distance you cover in an interval of time. It's the rate of change of position with respect to time. It's a fancy word. Equation, let's just use S for what? Everybody. Speed, right? D for distance, T for time. Technically, you can pick any symbols you want. You could say chickens equals fish over cows. That just gets confusing. Let's just try to keep it consistent. Speed equals distance over time. Units. This here United States of America, we ain't use no metric system. What do we use to measure speed? We use miles per hour. Watch out, right? 55th Street. Speed limit is, I see people pull over all the time. 35, there we go. And then what's that little street on the side? I think it's only like, Madison, thank you. I think it's only 30 there. So be real careful. Anyway, the rest of the world does not use miles per hour, right? They use what? What's the metric unit there? Kilometers per hour, right? So if you go to Canada, or you travel, you're in Switzerland, Pakistan, wherever, right? Any other country in the world except us and I think a little tiny country in Africa. Watch out, because usually it'll say speed limit 88, and you'll be like, woo, like I love these Canadians, and you're going 88 miles per hour, you're gonna get a ticket, because 88 miles per hour is closer to like 130 kilometers per hour, but really 88 kilometers per hour are 55 miles per hour, so you just gotta be careful. And as the world becomes more metric, you'll see like in the Olympics, in swim meets, track and field, it's all going to be in the metric units of meters per second. The next tricky idea we want to distinguish is what's called average versus instantaneous speed. Average is pretty easy, except it's easy to mess up when you do like math problems. You're tending to just do like a math average. How do you find the average of 3 numbers? It's real easy, right? You just add up the 3 numbers and divide by what? By 3, right? In physics, you can't do that. It doesn't work, because in physics, it's your real average speed. So if you drive 50 miles an hour and then 75 miles an hour and then 60 miles an hour, you can't just add up the 3 speeds and divide by 3. Because in real life, you might be driving 3 different speeds, but for different amounts of time, okay? Like when you're on a road trip. So to get your average speed, it's actually pretty easy. You just take your total distance over the total time. So what's weird is if you go on a road trip, your average speed might only be like 25 miles an hour, even though on the highway you can drive like 60 miles an hour, right? Why is that? Why is it in real life? Anyone ever been like on a family road trip? Anyone go this summer? And anyone want to take a guess? Why does it take a long time when you do a road trip with your family, or if you got young kids or whatever? I have to pee. I'm hungry. Right? So then you're pulling over at a rest stop. So then your average speed goes to 0 for like half an hour until you get in the car again. And then I try to make up for time. I go like 75, maybe 80. Oh, Minnesota, slow down, right? But then our average speed is like 35 miles an hour. It takes us like 10 hours to get there. So you just take your total distance over total time. How do you get the total distance your car is driven? Anyone know? Little trick, right? There's this thing in the middle of your speedometer. You ever see this before? Down here? What's this thing called? Anyone know? It's your odometer. Just kidding. Yeah, your odometer. It actually just measures the total mileage your car's traveled. So if you subtract the 2 numbers there, you'll get your distance you traveled divided by the time. You can get your average speed. Now, a cool example of all this physics stuff is a lot of you guys have this little fancy thing in your car. It tells you like where you are, where you're going, where you need to turn. It's called a what? GPS navigation system. Exactly, right? And what the GPS system uses is a system of satellites to calculate your position. And then they program in these equations right here to figure out not where your car is, how fast your car changes where it is, how fast it changes how fast where it is. That's acceleration, tricky one. And then it can compute average versus instantaneous speed by using these equations. Your instantaneous speed, what do you suppose that is? That's your speed at any what? What's in the word instantaneous? Instant. And what your car does is it takes a short interval of time to see how far your car went. So usually it's connected to like your tires spinning. So if the car manufacturer knows the circumference of your tires, then they can actually figure out that based on one rotation, the distance you'll cover, and based on that amount of time, they can give you your speed at any instant there. That's the one you have to care about when you're driving around Hinsdale, coming to school towards the end of the month. But officer, my average speed was only 15 miles an hour, even though I was just going 47 because I'm running late to school, right? So you got to be careful there. Got it? Here's another example that's a little bit more concrete. Let's say you're on a bicycle, and for the first hour, you ride 5 miles per hour, so you go 5 miles. For the next 3 hours, you put on a little bit of speed, but actually a little bit tired, so you actually only go 4 miles per hour. My bad. For 3 hours, you go 12 miles. And then towards the end, You just sprint for it. You go 7 miles per hour. Wow. For 2 hours, you go 14 miles. So how do you find your average speed for the bike ride? True or false? You simply add up 5 miles per hour plus 4 miles per hour plus 7 miles per hour, and you divide by 3. True or false? False. Thank you. That's not true. Your average speed for the bike ride is not simply the sum of the 3 speeds divided by 3. Why? I thought average just means add up 3 thingies and divide by 3. Why doesn't that work? Can you see here? Notice we only went 5 miles per hour for an hour. For the bulk of the ride, for 3 hours, we were going at a slower speed, and then only for the last 2 hours we sprinted, okay? So this could be like a really complicated problem, like you have to do a time-weighted average, blah, 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 blah. Too complicated. Make it easy. The definition of speed is distance over what? Time, right? So all you got to do is add up all the distances, 5 plus 12 plus 14, 17, 14, 31 miles, divided by the total time, which is 1 plus 3 is, 1 plus 3 plus 2. Help me out here. 6 hours. There you go, right? So if we did 31 miles over 6 hours, we could figure it out. That's okay. Okay, it's not about the actual number, it's the idea there.